Okay, Sanjay, I'm going to get started. All right. Welcome, everybody, to 52 Living Ideas. Delighted to have Sanjay back on this Comprehensivist Wednesdays, which we do in cooperation with the Greater Philadelphia Thinking Society. Sanjay has been doing amazing meetups on neuroscience, and today it's going to be really, really fascinating with neuroscience and art. So Sanjay, floor is yours.
So what we'll do is we'll go into some of the things that we, some of the things we talked about earlier in previous discussions will be a part of this, but I won't go into those necessarily as part of in detail, but we will reference some of those, and maybe in question and answer, people can ask if they're not sure about that. So overall, the topic is going to look at art, and I'm looking at art in a broad sense. So what does art really create, or why does art really create emotions in us? This is something that everybody notices, and it's not always obvious. For the simple types of art, or art that's obviously very evocative, it's clear, but there are other types of art that it's not so clear. For example, there are paintings by many famous painters who, it's not clear. I mean, especially the abstract types of newer forms of art. It's not so clear why they evoke emotions in us, especially negative emotions. So maybe, we'll go into some of the ideas around this today. And this is more a discussion to help people think about their own perceptions of art and how they perceive and how they interact with art. What I'm going to present is not necessarily, all of these things are not proven or established in the sciences. But what I'm going to do is present areas of information that we know about, for example, in our visual processing, to help people understand why there are strong emotions with certain types of activities. So why does art create emotions in us? What does art do within our brain or mind? Exactly after we perceive something. And again, I'm going to talk in a broad sense. We're going to look at examples mainly in the visual realm, but the discussion goes into pretty much every type of art and any type of perception that we have, not only visual. So obviously music, even taste, the gustatory taste. When you go to a very fine type of restaurant or establishment, all of these are areas of art, and all of those have very, very similar parallels in our mind. So the examples we'll use will be focused on visual because that's easy to discuss and easy to observe, but they apply to basically every type of sense that we have, every type of artistic endeavor that we have. And all of these bring energy and emotions and thoughts into our mind. So we'll go into some of that tonight. So is this, these precepts around art and how art affects us, is this built into us through nature, or is it something that we acquire in our early years through nurture? Or is it a both? Is it both of these, a combination? And what I've been learning, and what and in the sciences, many areas of sciences we see that it's actually a combination of the two. It's rarely is it only nature or only nurture. Usually it's a combination. The one sometimes initially has stronger impetus, and the other side of it takes over later. So we'll see in art also it's both of these. So for example, is it due to innate perceptual or behavioral habits that are within us? Is it due to learned cues and responses that we pick up from our culture? These are two examples, two ways of looking at the nature versus nurture question. And what we'll do is we'll look at, in terms of perception, in terms of our sensory perception, many of our senses develop in our early years, usually within the first year, they finish formation. And how they develop actually affects how we perceive things. But before we're even born, many aspects of our perceptual system are hardwired into our DNA through millions of years of evolution. So that's what this first bullet, talking about innate perceptual behavioral habits, that's what that's talking about. And the learned cues and responses is obviously learned through our social interactions as we grow. So art is all around us. I'm going to use an example of a type of art to help us to understand this. So one of the things, so every sensation we have can be experienced as art. every perceptual sensation. The visual sensations, paintings are obvious, sculptures, performance art, for example, dance, poetry recitals, comedy shows, fireworks, even deep sea snorkeling, although deep sea snorkeling is not really a performance art, but if you go into the ocean and you see all of the fantastic colors and the types of animals that are deep in the ocean, that will give you almost an artistic sensation, feelings of artistic sense. So that's an aspect of our visual sense organs, and it gives us artistic type of stimuli. Vibration. So I'm giving you examples that people don't normally consider to be artistic, but vibration. So if you think of musical performances, percussions, for example, the taiko drums, the kodo drums from Japan. These are very, very deep resonating types of drums that almost resonate through your body when you hear them. That vibration is picked up through our auditory system, through our ears, but it's also picked up through our skin and our bones and the rest of our body. So that's an example where our sensations are not only picking up from one organ, we're picking up from multiple organs simultaneously. When you go to a movie theater, and if you're going to a movie theater that has special effects, sound effects, they may use either high-pitched or very low bass type of sound effects, which cause different types of sensations in your body. So that's another example of vibration, use of vibration to communicate in art. Visually, there can be a sense of imbalance. So we have a balancing system. So in the next slide, I'm going to go into the types of sensations we have. We talk about the 5 senses, but actually there are more than 5 senses. Balance is one of those senses that's not recognized by most people. But if you go to a movie, or if you go to any type of video that you see where somebody is spinning, or it may be that the camera ends up spinning round and round and round, and so you, the viewer, are made to go through this spinning motion, even though you're stationary, you're sitting probably, yet your visual system is made to perceive a spinning world, through, let's say, a movie, and that can make us dizzy. So that's a confusion between our balancing system, which recognizes that we're not spinning, but our visual system is getting this sense that we are spinning, and it causes this confusion. Another example is if you watch a painting, a very well done painting, which shows a scene at the edge of a cliff, and you may get a perception of vertigo from watching that painting, or a photograph, especially if it's very realistic. So these are examples where visual stimuli can actually cause imbalances. Lastly, we have taste. Taste is another. So I'm using the non-traditional senses to give examples of where art can affect our perception. So taste of salty ice cream, caramelized sweetness, caramelized onions, many foods have, right? Fatty roasted cashews, roasted nuts have a lot of fat in them. So these are examples of tastes which are non-traditional, but they give us a very pleasing type of sensation, which many people would consider artistic, especially if you have them at a fine dining establishment, or let's say somebody who's really a good cook. If they make something like that, you'll have a artistic sense of appreciation for the food. So let's pick one type of art form, and I have 2 different videos that I want to highlight just in the beginning to get us to understand many of the aspects of art. We're going to look at performance dance. So some of the elements in performative dance activities, there are visual sensations. So there's fast-moving, very precise positioning that the dancers do. They gesture with their hands and faces and body, right? And there's this thing called proprioception, which some of you may be aware of, but proprioception is basically, it's another one of our senses that's innate. And it's the sense where if you close your eyes and you move your body, let's say you close your eyes and you move your fingers to your nose, you can exactly touch your nose even without looking, because your body has a sense of exactly where your limbs are, where your different parts of your body are at any time in space. And that's proprioception. And in dancing, that is absolutely essential. Every dancer relies fully on that because they're making so many complicated motions very, very rapidly. And their ability to know where every part of their body is vital to their ability to perform dance. But we as viewers of dance, actually, we have mirror neurons. So this is something, I'm speculating on, but it's possible that our mirror neurons in us as the viewer of a performance art may actually get evoked when we see a dancer, let's say spinning or doing something very intricate, some type of very intricate movement, which seems challenging, which we know is challenging, may cause some sensations in us and activation of our proprioception.
Sanjay, let's do one more thing with the sound. There is a hissing sound that is coming with it. So let's just change from highest level to automatic in the audio settings. So click on up arrow, audio settings, and make it automatic.
All right, it's done.
Yep.
Is that better? I just noticed the
Go ahead.
the microphone setting. It's showing low volume. Well, sometimes it depends on.
Oh, okay. Can you? Okay, you can put it instead of all the way to the top, put it at around 80% or so.
All right. And also, I set it on automatic.
Okay.
Let me. Yeah, automatic should probably be fine. I'll set it on.
Sure. Go ahead.
So, so another area of performance dance is that there are sounds and vibrations that we in the audience feel, and obviously the performer also feels the same. So there's musical accompaniment with dancing. There may be beats that different types of art dance forms incorporate beats, sounds that the performer actually causes to occur, and for example tap dancing. And so that we will obviously hear, and they have to be, you know, our sense of artistic appreciation relies on the synchronization of these elements, excuse me, of the sound and vibration to what we visually see. Again, balance is something we talked about earlier. So we may feel an awe by seeing somebody, dancer, who is continuously spinning round and round and round, you know, 8, 9, 10 times without spinning or without falling, or by seeing them perform certain types of acrobatics where one performer throws another performer up into the air. They twirl around and they catch them again. And all of these involve balance for the performer. And then there is music, which, so sound and vibration is different from music. Sound and vibration is not necessarily melodious, but music is melodious. So there may be singing involved. There will be movement and possibly the song that are synchronized with the music. So all of these are different elements of dance performances. Just the simplest elements, there are much more, but I'm just laying out the groundwork for some of these initial elements. And we're going to watch two videos, brief videos, they're about a minute each, that give examples of some of these. And I'll talk through some of these. And the first one does not have any sound. I wasn't able to get audio of that. The second one does have sound, but so this is a performance of what's known as Bharatanatyam. My daughter took this type of dance for many years when she was younger, and this is an ancient art form in India, believed to be around 3,000 years old. And what you're going to notice is that the three dancers, they're synchronizing with each other. They are posing in specific poses. They're moving their hands in specific positions, right? Their poses, again, with their hands and their bodies. Their facial expressions are important. And if you could hear the music, you would hear it was synchronized. You can actually see some with their feet. They're making sometimes tapping sounds with their feet. So these are all elements of performance dancing, right? That we're familiar with. There's even though we don't hear the sound, we can sense there's rhythm between them, right? We can sense that there's synchronization between them. Now, one of the things that dancing does is most types of dancing actually tell a story, okay? Because dancing and all art forms communicate to us, all art forms. So this is the next one. This has sound. I don't know if the sound is loud or not. So this performance is actually, you're going to realize it's not a normal ballet. It's a humorous ballet scene. Okay? And I chose this intentionally because I want to highlight some elements of performance art. So here, what we see is that we can't see their faces as well, right? But we can see their body. And so I'll let everyone watch for a minute. It's okay to laugh. This is intentional, humorous dancing. These performers are very good. They're very good at doing what they're doing, not only the dancing, but also the humor part of it. Right, so that's the end of that. So actually, I just had something in here about fair use. So I have several art pieces in this presentation, and I just wanted to put a slide up for fair use. A lot of the art pieces, many of the art pieces are out of copyright, but there may be some that may be considered. So I just wanted to put that slide up for a few seconds so that if there is any issue, we're addressing it, and we're doing this in a legal way. Even the art pieces that are, so those two videos possibly may have some copyrights around them, and I use only a snapshot of them. They're very low resolution. So what I wanted to the videos that we just saw, what I wanted to explain is that we are in dance, we see that well, pretty much most performance type of art is communicating with the audience, right? And usually it's a one-way communication. The clapping is one type of feedback that you can give, or sounds or certain types of emotional responses, oohs and ahs and exasperations. These are a secondary communication that occur between the audience and the performers. But usually it's primarily a one-way type of performance between the performers. I'm going to stop the video presentation for now. So I'm just going to talk, excuse me, for a minute now. So I don't know if my video is showing or.
Just a second. I just want to ask folks, how bad is the sound? Is there a lot of disturbance? Is it, how are you seeing it? You can just type in the chat. Is it okay? It's okay. All right. It's fine. Not too bad now. Okay, perfect. Go ahead.
So what I'll do, so I'll just briefly talk about art in general. And so all art is a form of communication, and it may be intentional, it may be unintentional, but there is some type of communication that the artist or the performer is trying to do with others. And the communication is not very exact. It's vague. There are many types of art which are more, some types of art are more exact than others. Some types of art are more vague. So performance art and dance especially is a little more difficult for people to understand, because even though they're telling a story, we need to understand the language of that art form. So ballet and Bharatanatyam, they both have a language that they're both very formal types of art. They're very technical. And there's a language that most people would not recognize. But if you do recognize it, you'll appreciate more of it. You may even be able to pick up on the gestures and possibly the story that they're trying to tell, especially if it's a new piece that you're not aware of. So going into art, so all art relies on our senses, right? And we have, we have been given this sense that we have 5 primary senses. And that's actually a misnomer that was created years ago by Aristotle. So going back into history, Anaxagoras, he was a famous, well, not famous, he was a Greek philosopher, one of the first physical philosophers. And we would say that he and the next one, they both were akin to doctors, although the concept of a doctor didn't exist back then in the way we think of it today. So Anaxagoras considered that humans have 4 senses. Okay? And that was the first in history that at least in Western history, that I was able to find of a reference to how many senses we possess. Alcmaeon in about 50 years after him, said that, and he agreed that we had 4 senses, and he said that those 4 senses are connected to our brain. Okay? And this was significant because this was the first time in history, in Western history, where we are looking at our perceptual system and recognizes that we have multiple specific sensory organs and they connect into our brain. And that's very important. Now, Aristotle came about 150 years after that. Unfortunately, Aristotle took us a little bit back because while he did say that we have 5 senses, he did move us forward in that direction. What he said, and most philosophers after that point started agreeing with him, is that he said that these 5 senses work through our heart. He didn't consider the brain to be an important organ. He considered the heart to be an important organ because the heart moved, and movement to him was an essential element of things in the world. So he considered the heart to be the primary organ that dealt with the senses. And since then, that's how we've been looking, not the heart part. We've learned about the brain, but the 5 senses is what we've been using. So actually today, neurosciences consider that we may have up to 33 types of senses, sense receptors. And the 5 first that we talked about, the Aristotelian ones, the auditory, gustatory, so the hearing, taste, smell, sight, and touch. These are the 5 ones that Aristotle came up with. Now, touch actually consists of more than just the simple type of touch that we perceive. Touch actually expands into many other types. For example, the sensation of pressure, vibration, pain, hot temperature, cold temperature. There are a few others, but these all correspond to our sense of touch. We have very different types of receptors in our body and skin that allow for that. Then we have some visceral sensations in our body. Proprioception we talked about earlier. Balance is another, which is a little bit linked, but it's not the same. Internal equilibrium. There are many types that those who are doctors who will recognize that our body tries to keep various systems within our body in equilibrium, and there are sensory organs that are related to that. For example, hunger, urination, nausea, these are other visceral types of sensations that we have. So there's more than just the 5 sensations that we have. And while many of these, the visceral ones, usually don't come into contact when we're experiencing art, unless if it's dance, the vibration aspect of it that's one that comes in many forms, but most of the other ones don't usually come in. If you're in a performance art venue, which changes the temperature of the venue, makes it very cold or very hot, then obviously you might. Or if you're at a music concert and the sound is so loud that it's actually causing pain, then yes, you may experience pain. So, but usually the senses that we experience are the 4 ones that we typically, well, two primarily and possibly a third. The auditory and visual are usually the first 2 that we experience. Now, our senses, and all of these senses that we have, they develop in the first 6 to 9 months. Develop meaning they become attuned to the world that we live in. They're formed in utero before we're born, but they're actually not very functional at the time of birth. At the time of birth and 4 months later, our body is actually learning to develop and form our senses. So for example, our visual system, and depending on the intensity of light, for example, if you grow up in an area where it's very dark, okay, the polar extremes on the planet where parts of the year it's extremely, extremely dark, your visual system will develop in different ways. Or if you live in certain areas where the temperature is very hot, your senses and your sense organs will develop in very different ways, and they will not change for the rest of your life. They'll kind of become locked into that. And that's for a reason, for that reason, we recognize that if a child, for example, if their eyes are, if they grow up in an environment where their visual system is not stimulated, or their auditory system is not stimulated well enough, those systems actually develop up to a point and then they cease development, and it causes long-term deficits in that child. So this is the reason why we really need to help develop our senses early on, and only then do we get most out of it. Next, I have another video that we're going to look at, and this is going to show some of the interesting aspects of our visual system. Okay, so this is a video that I'm showing a static picture from Van Gogh, Starry Night, and there's going to be an animation after this video. this animation, what I want everyone to do is I want everyone to look, the animation is going to be a spinning type of wheel. And I want everyone to keep looking at the center of the wheel. The wheel is going to spin for about 30 seconds and keep looking at the center of the wheel. And you're going to notice something afterwards that we'll talk about. So I'm going to start this now. It's fairly interesting and surprising. What I want people to understand is that after this, the sensation that you have is not artificial, it's real. You can watch this video later and you can pause it in the middle, or you can play with it in different ways, so that you understand this is really an element of our visual system. It's not artificial. It's not generated using any artificial means. So let me start the video. And keep looking at the center point. Just keep with both eyes, you can blink normally, but keep your gaze on the center point. And after about 25 more seconds, we're going to have something that's going to be, I think most people will find it quite interesting. So what's happening here is that our retina and the visual processing centers of our brain are being kind of programmed by this visual stimuli. Okay, so now you see the same picture that we had, painting that we had earlier. I don't know if people can notice anything. Do people notice any unique aspects of this photograph? I don't know if anyone noticed. If people noticed, you can definitely put something in the chat. What type of experience you had. Yeah. So so I don't know if I can't see the chat right now, but if people, Shrikant, can you read some of the types of comments people had?
Sure.
And if we don't,
clouds are moving. It's supposed to be moving, but it's not moving for me. It is shifty, vibrating. The painting vibrated when we returned to it. I see nothing in mine. Looks like it's going one way and then the other, which increases over time. Someone says didn't change for me.
Yeah, if you weren't watching it, the center point, or maybe there was video issues, we're going through streaming, so it's possible the video froze or something, in the middle. But if you watch this on your own separately, you'll understand the effect more. When what basically happens is that, let me actually flip back to, so this painting, and I don't know if is my arrow visible? I'm moving it to the top section.
Yes.
Okay. So what most people will see is this topmost portion of the painting, which denote clouds or turbulence in the painting that Van Gogh, when he initiated. It's kind of denoting turbulent sky, right? Maybe wind, maybe clouds, maybe gusts. And after we saw this animation, especially this region, but other regions of the painting would have begun to move for us, for anyone who experienced this illusion. And it's not really an illusion. What's happening is that our mind is actually doing this. It's not that our mind is fooling itself. Our mind, during the time that we were watching the animation of the rotating pattern, the black and white pattern, what was happening was one of the earlier processing centers of our brain, and we'll get into this a little bit further, it was getting experience for a significant amount of time, 30 seconds or more. And if you do that for longer than 30 seconds, it'll have a stronger effect. So what's happening is that the brain is seeing this rotation, continuously rotating. And after a while, it starts to think, well, this is what the world is like. It starts to assume that the world is different now, that the world is a rotating world, that I'm living in a world which is spinning in this sense. So what the brain tries to do is it tries to compensate for that. And it tries to, or I'm not sure if compensation is the right word, but it's what's happening is in the state of the visual cortex in the brain assumes that there will always be motion of a certain type, of a spinning type. And the neurons in the earlier regions of the visual processing centers will start to do the same thing that this rotation is doing. They'll start to send messages to each other that simulate this rotation. Okay. And so after the rotation stops, after we stop that rotation, you go back to a stationary image of this painting. The brain doesn't know that the world has changed. The brain thinks the world, we're living in this rotating world, and the neurons are still causing this rotational behavior amongst themselves. Irrespective of what we're seeing, the neurons don't know that things have changed. It takes time for the neurons to learn that. So after about 15, 20 seconds, the neurons eventually figure out that, okay, now the world is no longer spinning. And then you start seeing the image as a static image again. But during that interim period, the neurons get really confused because what the neurons are doing, they're trying to match a pattern. They're trying to understand what the world is like. They believe the world has fundamentally changed. The visual world has fundamentally changed. They believe that everything is spinning around us. And so the neurons try to kind of work with that. They try to adapt to that. And that adaptation, short-term adaptation, is what causes this type of stimuli. It's very interesting, but it actually happens. So with our visual system, we're going to delve a little further into our visual system. Okay? So we have our eye and our retina. These are the two main parts of our, outside of our brain, these are the two main parts of our visual system, which convert photons or light from the area in front of us. They convert them into electrical signals that are passed into our brain. And the cranial nerve, the second cranial nerve, is, or also known as the optic nerve, is what carries the intensity of the seeing of individual photons or individual, you might say, pixels. It carries the color information of various pixels. It carries contrast information, and it carries the spatial information of how all of these different colors and intensities are spatially laid out in front of us. So all of this information goes into our brain, and it first goes into areas of our brain that do pre-processing. For example, the optic chiasm is one of the areas where it actually takes the signals from our two eyes, and it does some very interesting, I'm not going to go into detail, but it does some very interesting transformations. So actually our eyes, each of our eyes is split up into 4 quadrants, and it mixes these 4 quadrants in interesting ways and sends the correct information to the correct part of our brain, to the occipital lobe, which is in the back of our brain. It also sends this information to other parts of our brain. For example, parts of our brain that are responsible for sleeping or balance or other areas, not so much the thinking part of our brain, but it sends it to our more primitive parts of our brain, which rely on vision, very rudimentary aspects of vision. So this is pre-processing. And then it goes into the primary processing. This is really what we think of when we talk about interpreting what we're seeing. And it's primarily in our occipital lobe, which is in the back of our brain, area called the visual cortex. And this visual cortex actually processes the aspects of what we're seeing into different characteristics. And it derives these characteristics from real world objects and from trying to comprehend the scene in front of us. But these are more advanced, these are the more advanced types of processing. They're actually even lower level processing that we'll get into in a few slides. And then lastly, after our visual center has kind of made some sense of what we're seeing, that information in encoded form gets sent on to other parts of our brain. So this visual information then gets merged into other cortical areas, for example, our temporal lobes or our frontal lobe, which start to, or our mesolimbic system. So they go into other parts of our brain and they start to form emotions and thoughts around what we saw. And this is exactly what happens when we see art. When we see art, the pure visual stimuli that we're seeing gets processed by the lower centers of our brain, the more fundamental centers of our brain. They get parsed out, and then they get parsed into somewhat of an understanding of what we're seeing. And that understanding gets sent into our emotional centers, into our other centers of our brain, into our thinking, the prefrontal or frontal lobe. And then that actually begins the point at which we start to assess, or we start to understand, we start to examine exactly what it is that we're seeing. What is it evoking us? What feelings does it bring in us? So these feelings and recognition start to occur in multiple regions in our brain. And these happen in parallel, in simultaneity. One of the previous discussions we had was that in our brain, we have multiple regions of our brain that are always acting in parallel at the same time. And this is also happening when we're appreciating art. And actually, the discussion tonight is about appreciating art, but the same things actually happen when an artist tries to create art, except it happens kind of in reverse. If they're a very astute artist and they understand the processing that our brain does in the various types of art, if they're a musician, then they'll have some type of understanding of how music is processed in our brain, not from a scientific point of view, but from an intuitive point of view. They'll understand that beats have a certain type of sensation, or rhythms have a different type of sensation, or a music scene or a music scape, can be created, which gives a sensation, different sensation through music. And these same elements have parallels in the visual and every other type of perceptual system we have. So the artist, if they understand how these interactions happen in the brain, they can use that to create the type of art piece that they want and to evoke the type of reactions that they want in the audience. That's one of the most important aspects, is that good artist understands these aspects, and they can intentionally create certain types of reactions in people. And one of the things I want to bring up is in the ballet piece that we saw earlier, okay, it was comedy, right? Now, what told us that it was comedy? There was nothing there that gave us an impression that there was a comic scene. Well, in the first few seconds, you probably would not have even picked it up. And only after one of the ballerinas fell, you might have had a shock, right? You might have had a sense, and even then you might not have had a sense that it was humorous, that it was comical. So what actually happens, and people who are comedians have, or if you watch interviews with them, you'll hear them say the same thing, is that comedy at its core actually has stress. At the core of every comedic situation or every joke or every laugh is stress, human stress. Okay? So when we see somebody slip on a banana peel or a ballerina fall on a performance stage, okay, it evokes stress in us. But that stress happens so quickly, and it happens at a deep level where we're not aware of it. It's not conscious. It happens at deep levels. But that stress causes a reaction in us, and that reaction has to be dealt with in our mind. Okay, and laughter is one of the ways that our mind has learned to deal with some types of stress, which we perceive as humorous. Okay, so slapstick comedy, people are aware of. That's an example where there's a lot of physical humor, but usually the physical humor has pain or some type of feeling of pain associated with it, where somebody is physically getting, it's not serious, but in a slight way, they're getting hit somehow, maybe with a pie in their face or something else. So that's an example of the stress that causes. But art can cause stress. Art can cause emotions of other types, not only stress, But comedy is an art form because it relies on stress to be communicated to the listener. Right? So the types of feelings and recognition that we might have. So the initial types of feelings that when we look at an art piece are colors, shapes, textures. We may recognize specific objects. We may recognize the entire scene, okay? And the many, many other elements. So these are all interpreted in our mesolimbic regions. Actually, they're interpreted in the pre-processing centers, and then they're sent to the mesolimbic system. So sometimes we call them the limbic system. Parts of the limbic system, not all of them. Then we have primitive programmed habits, okay, which are, you might think of these as habits in our perceptual system, not just in our visual system, but also auditory, in our gustatory. Each of our senses have these habits that are programmed through evolution. For example, our taste receptors, we have 4 taste receptors, but we also have taste receptors. We recognize 4, but we also enjoy the taste of fat. Okay? So one of the taste receptors is sugar. Okay? Bitter, sour, sugar, and I forget what there's a 4th. Anyway, and then there's fat. But fat is not recognized as one of the taste receptors. It's not a taste receptor, but it's a different type of receptor. But fat is very important for enjoying food. That's the reason why any food that we consider delicious is either sweet or is fattening. These are the 2 fundamentals in all foods that we consider tasty. And that's because our biology has programmed our taste receptors to look for sugar or fat, because sugar and fat are dense in energy. They are very simple forms of energy that our body can metabolize very quickly and make very rapid use of. And our body needs energy. Our body relies on energy. So our taste buds have evolved to look for sugar and fat and to give pleasurable sensations when we taste sugar or fat. That's the reason why most unhealthy foods tend to have either sugar or fat or both. So this is what I mean by pre-programmed habits. They're not habits the way we think of habits, but they are habitual in the sense that they're in a sort of memory. They're in our brain, existing there from before, from time of birth. Then we also have emotions and cognition that rely on our memory. So for example, our experiences throughout the world, if we've seen certain shapes and objects in the past as we've grown up, then the pieces of art that we're experiencing will evoke those same memories. If we've seen a dog that's only been a certain size, right? If we've only seen small dogs throughout our lives, and the painting has a very large St. Bernard or a very large dog, then that artist might, that painting might create a sense of disjointedness or a slight bit of stress in our body, in our mind, because our mind remembers and recognizes only small dogs. But this painting that we're seeing of a St. Bernard is this giant dog, which doesn't mesh with our sense of reality, which our sense of memory in the past. Yet our mind tries to make sense of it. Yet there are other elements of that painting where we'll be able to recognize it as a dog, or if the paint, depending on the painting, we might not. So that might be an element that an artist plays with. They might portray a dog in ways where it's not obvious that it's a dog. For example, they may not use any fur at all, okay? Where it becomes very difficult for us to understand if it's we may recognize that it's an animal by the features that the artist portrays, but we may not recognize that it's a dog because the type of fur that an animal has actually is very indicative of how we recognize it. So an artist can play with many elements of, for example, texture. Texture is what fur is. Fur connotates texture in our visual system. Color also, if they give pink fur or if they give a pink skin to an animal, that will evoke a different sense, right? Like a worm might be pink, a guinea pig might be pink, a pig might be pink, but most of us have never seen a pink dog or a pink horse, right? But if the artist colors the animal pink, that's going to give certain cues to our mind, and our mind is going to look for pink animals and try to interpret the art as if the artist is intentionally trying to portray a pink animal, but the artist's intention may have been to portray, to deceive us or to represent something in an unusual way. So lastly, and as we saw in the previous example, illusions exist. Our perceptual systems have illusions built into them. And so our senses can be fooled or deceived temporarily. Usually they recover after, within a minute or two, but they can be fooled very, very, very easily in some cases. What we'll do is we'll talk about, and after this slide, we'll pause for some questions and answers. So our visual system, we'll look at the retina. So this is an image of an actual human retina. This is the left retina. And the yellow region on the left side is the region where the optic nerve terminates into the retina. Now that area is actually an area where we don't have any vision, okay? Or the vision is almost non-existent. That's actually a blind spot. Everybody's eye, both of our eyes have this blind spot, okay? And you can actually find the blind spot if you're astute, if you're careful, if you hold both of your arms ahead of yourself, and you put your two thumbs ahead, arm's length, and you kind of put it in the center of your field of vision. And if you, with your, I'm trying to think if I may have the order reversed, but with your right eye, if you move your two thumbs slightly to the left of center, okay, just a few centimeters, move it slowly, you're going to find a region where your two thumbs disappear, or a part of your two thumbs literally disappear from your field of view. Your hand will be there, the rest of the background scene will be there, but a part of the nails of your thumb will basically disappear. And that's the area of the optic nerve in that eye, and you have to do it with one eye at a time. So that's important because part of our vision is actually, we have blindness in our vision. The center part, the gray region in this image, is called the fovea, and that's the area that actually is where we have real vision. Okay, most of our retina has very, very poor vision. The fovea has very, very high resolution vision. So if you think of a camera has high resolution vision everywhere. Our retina and our eye does not work that way. And that this is because of, for evolutionary reasons, for conserving energy and conserving many aspects, our eye developed in this way. But the fovea has very, very dense retinas and has very high perception of color and intensity. And the rest of the retina has low resolution and low detectability of both color and intensity and contrast. So what's actually happening when we are awake and looking at the world around us is that each of our eyes is actually having micro movements. It's always moving very, very rapidly, but very slightly, okay? And what our visual system does is through that motion, our eye basically kind of cancels out the blind region of the optic nerve, and it moves the fovea around to a much larger region, which basically expands the high resolution area of what we see. But our brain is always keeping an image of what we see. So our brain is keeping an image. We're actually not seeing a high resolution image of the world around us. The image in our brain is artificially created to give us a perception that we have high resolution everywhere. But if you look on the periphery, if you move your arm around to the periphery, there are points where you are not able to see, especially if you take a very, very thin type of pencil or something even thinner. If you move it toward the peripheral edges of your vision, you're going to find that it disappears quicker, again, because our eye is not keeping a lot of high fidelity. So some of the important points here. So there's a study, this is a study from 2016, which is fairly important. Actually, there are many studies, but this study I wanted to highlight because it helps us to understand aspects of our visual system, and especially with relation to art. We're going to get into that just in a minute. So what this is showing the retina zoomed in. This is a representation. It's not an actual photograph, but it's a representation of the retina. Specifically, the cones. Cones are the color sensing regions in our retina for two different subjects in the study. And what you're going to see in the central area, which have white circles, actually, if you look at the center of each of those white circles, are the color. Those indicate the color of the actual those cones. So what you're going to see is that most of these cones, the majority of cones in both of these subjects, are red. Okay, and the table on the left side that just popped up, this gives a representation of in these two subjects, and it's very likely that these statistics are suggestive of all of humans, every person. At roughly 63%, almost 2/3 of the cones in our retina are red cones. They perceive the color red, and they're tuned to perceiving only or mostly the color red. Okay? Around 1/3 of the cones, 31%, are tuned to perceiving the color green. The remaining amount, a very small number, roughly 6%, perceive the color blue. And actually, the color blue perception of color blue, depending on the type of animal, including humans, varies depending on the top of the retina and the bottom of the retina. And that's because the sky is primarily blue, which means that in our visual system, we need to perceive blue in the lower part of our retina. So the lower part of our retinas, most mammals have more blue receptors, blue cones, than the upper part of our retina. Okay? So this is an example where our visual system through evolution has evolved to look for the color red. Okay? The color red gives a stronger signal to our brain than the color green or the color blue, but the color blue gives the weakest signal to our brain. Now, this is actually opposite to what physics tells us, because if you look at the electromagnetic spectrum, light is, color and light is an aspect of the electromagnetic spectrum. And the spectrum, the color red actually has less energy than the color blue, but here it's opposite in our brain. And this may have been, it's hard to say exactly why. Probably, it's multiple aspects that, the nature of physics or the nature of the world around us, but also maybe that there are more red things that are important for us to notice in the world. Maybe red became symbolic of both sources of food and sources of danger. For example, there are many animals that use red markings on their body, spiders and snakes, for example, that use red, and even poisonous frogs, that use red color to indicate to other predators that they're dangerous, not to eat them. Okay, so this is a survival mechanism for them. But for us, when we see red, it evokes either a feeling of fear or some type of strong reaction, or there are many types of fruits or foods, and vegetables that are red colored. So either for food reasons or for safety reasons, or likely both reasons, our visual system evolved to look for red primarily, and then green, and then blue lastly. Okay? And this is important because we're going to go into, and the last point I want to make on this slide is that our visual system actually is not as simple as we believe. Most people have three types of these red, green, and blue types of cones. Okay? And these types of cones actually don't pick up red, green, and blue. The red cone actually picks up parts of the green, and the green cone picks up actually green and yellow, and even slightly some of the red and slightly some of the blue. And the blue picks up mostly blue, but also picks up what we might call ultraviolet, but not really much of ultraviolet, very purplish color, and a tinge of green. So there's an overlap between these three cones. And most people have three cones in their eyes, but some people for genetic reasons are born with two color sensing cones. And the one that's missing will determine the type of color blindness that they have. Usually red-green color blindness is the most common. That's where the green cones are missing. And this is based on evolution, because out of the three cones that we have, if you look in evolutionary history, the first types of animals had no color sensation. They only had intensity sensation. Then the first color sensation that came to being was red. The next one that came to being around 500 million years ago was red-blue. And the third one that developed around 35 million years ago was green. And so some humans actually lack that green because of genetic reasons. And there are actually a small number of humans, people, roughly a quarter, who actually have a fourth color sensing region, which is, it's an offshoot of the green, which gives them a sensation of yellowish orangish, or green-orange, gives them a sensation which can't be described because most of us don't have that. But they actually have four unique color sensing cones in their eyes. So let's pause here for a few minutes, and take some questions and answers.
Thanks. Do you want to stop sharing the screen? Thanks.
Yes.
Excellent. So folks, it's time for Q&A. As always, we have the 4 rules. Rule number 1, type exclamation mark in chat or raise your hand in Zoom in order to ask questions. At this point, questions only, because we want to get to as many questions as possible. Number 2, keep on topic. Number 3, be brief. Number 4, feel free to disagree with anybody on anything and do so courteously. So it's going to be Claudio. Give me just a second. It's going to be Claudio, Maritza, and Joe. Claudio, go ahead.
Well, hello, Sanjay. Earlier you mentioned that the sense of taste was acquired very early or primitively during the human evolution. I'm assuming you mean like very early on in the. So among all the human senses that were acquired during human evolution, I'm wondering, you don't have to list them all, which ones do you believe were acquired more recently or in the later stages of human evolution? And also part 2, is it still possible to acquire more senses that we don't currently have sometime in the distant future? Are we still evolving? Okay, thank you.
It's very hard to say which senses evolved in what order. Vision most likely, well, actually, if you focus on the so-called 5 primary senses, you'll get one answer, but if you include all of the other senses, the answer will be different. So one of the things we know is that and this is something we've talked about in a prior talk, but our brain actually evolved later in our evolutionary span, okay? And our brain actually evolved to replace our endocrine system. And our endocrine system, it kind of took the function of our brain before we had even sophisticated brains. So for example, worms and insects and even earlier types of animals that had very, very rudimentary, you wouldn't even call it as a sensing type of brain. Their endocrine system had neural cells, and our endocrine system still has neural cells. That's why in our viscera, we have neural cells in certain areas. And those are remnants of our evolution when we were worms, so to speak, or when we were, simple insects. So those senses evolved probably earliest, okay? And then as we developed, it's likely that vision, not vision the way we think of it today, but the ability to perceive photons, just ability to perceive light in a direction. So for example, when we were organisms in the ocean, the ability to know where light is above you, right? Because in the ocean, especially as you go deeper and deeper, light becomes more and more scarce, it becomes darker. So the ability to know which way is up was an important, and if you're in the ocean, especially if you're in the deep ocean, buoyancy counteracts gravity. You can't rely on gravity to tell you which way is up and down. So light became an important sense to detect which way is up. And probably we developed a sense, a very simple sense to detect just photons, not color, not vision, just which way is up and kind of light is coming from. And to this day, sharks have this organ in their snout, which kind of does that. They actually have other organs. They have other sensory organs also, which we don't have. They have sensory organs that can detect electrochemical and magnetic signals, which we don't have. Birds have that. So as far as evolution, we are evolving, but for us to evolve new senses will take millions of years. It's not going to be anytime soon, and not in our lifetimes.
Wonderful. Next up is going to be Maritza, Joe, Liz, and Ed. Maritza, go ahead.
Hi, Sanjay. Hey, you mentioned earlier in your presentation that within the first 6 months of life, we've settled in on our senses and that they're set for the rest of our lives. So and then you mentioned this more recently towards the end of the first part of your presentation, you brought up some things about genetics. What role, if any, does genetics, like, for example, if I may make the joke occasionally, oh, it's my island blood, it's why I'm cold. But, I've lived here most of my life where it does get very cold. So is that just, our brain playing tricks on us, or is there actually some genetic component, whereas if one's, ancestry is from a different region, do our senses remember things from a genetic perspective?
Yeah, interesting question. So answer is really both, but it's very hard to tease out which parts of our senses are affected by genetic predispositions and which part are learned. Though there are some things that we can speculate on and probably we can be sure of. So for example, if we look at temperature, right? It's possible that there's some level of hard wiring of a set point range of temperature that happens through our ancestors and multiple generations of us growing up in a certain area. So for example, if you grew up in Norwegian climate, okay, for 15 or 20 generations, it's possible that your the receptors of especially cold and hot sensation in your skin would be tweaked in one direction or the other, okay, through evolution, not evolution, through the simple genetic heredity, but also the fact that after we're born, our senses are not set. And what I said, let me clarify. When I said that it's not the first 6 months, it's 6 to 9 months. It could be up to a year. It depends on the senses, depends on the person. And also, it's not that it's fixed. It becomes fixed after that point. Most of the initial types of processing that our brain has multiple reasons of processing for every sense. Okay? So the preliminary processing centers of our brain, those regions become pretty much fixed in the first part in our youth. Okay, but they can shift slightly over time if we have different experiences. For example, if you're living in a very hot climate and you move to Norway, okay, then after a few years, you'll get acclimated to the environment there. Whereas before you move, you're going to feel much colder because your body set point temperature for your body for what you consider comfortable temperature would be more along the lines of a hotter climate. And Norway would not give you that hotter climate. You'll feel uncomfortable, but over time, over probably years, your set point will shift. There's a field of epigenetics which basically started around 15 years ago, and that's a very powerful area that's giving us a lot more insight into how. And so epigenetics deals with the individual. It's no longer about heredity or evolutionary past. It's only the individual and how our genes get expressed. Depending on circumstances, depending on experiences we have, depending on what happens around us. So for example, if we're living in a much colder environment than the one we were born in, our cells will live and survive and need to survive in a colder environment physically. So the expression of the genes may be different. I mean, they likely will be different. So if there are genes that affect cold temperature sensation, hot temperature sensation, one or more of those genes will be expressed more likely, more prevalently and less. So after a few months, all of the genes, because our cells regenerate over time, right? So all of the regeneration of our cells will cause over months and months and probably years, will cause all of our newer cells to have a different set point. So hopefully, I mean, it's both. It's a combination of both nature and nurture.
Thanks. Next up is going to be Joe, followed by Liz. Joe, go ahead.
Hi, Sanjay. I'm interested in how our psychology impacts our senses. So the idea that you spoke about the ability to laugh as a stress reliever. And I've heard, many times that people have spoken about their inability to laugh at different points in time. So that is because of their psychological state. So how does the psychological state relate to our senses in the sense that it prohibits us from reacting in certain ways? And how does that relate to other parts of your discussion in the sense of even how you appreciate art or things of beauty or determine what is beauty?
Right. So another very good question. So in previous talks, we've talked about how there are multiple regions of our brain, and all of those regions of our brain are processing simultaneously. They're always active, they're always doing things, and they all have access to information from our senses. And the information from our senses get dispersed into multiple areas of our brain. This is normal. And you have to remember that you think of our brain as having three types of, in a earlier talk I described, a very simple model is to think of our brain as having three different smaller brains, right? The primordial brain, the limbic brain, cortical limbic brain, and the cerebral thinking brain, right? The more modern brain. And each of these three brains are always doing things simultaneously. They're getting, eventually they get the information from our senses. So for example, vision, although they get them at different times. The earlier parts of our brains, because of how our brain the topology is structured and how the wiring happens, they get that information first. This is the reason why when you see something that causes, like something that would be comical, okay, it would cause, it goes straight to the stressful parts, emotional centers of our brain before our thinking mind even realizes that we're looking at humor. And that stress is not perceived because awareness happens mostly in our prefrontal cortex, in our frontal lobe, not in the other parts. There's some elements that happen in other parts of the brain, but most of awareness, what we think of as conscious awareness, happens in our frontal lobe. So that, that awareness of that stress would not be there, right? So if you see somebody falling, the deeper regions of our brain would sense the stress. They would have these emotions created within them. Our thinking mind would not be aware of it at all. And after a few milliseconds, probably a few seconds, our thinking mind would start to realize that we saw somebody fall. It would realize there may be pain involved. And then there's this, and then, there are multiple regions of our brain have these emotions, which may be different emotions around what we just saw. And then the rest of the time, our brain is trying to resolve those conflicting emotions. And they may be conflict or they may be supporting us. For example, in some situations, all of our regions of our brain may have similar emotions and similar feelings to what we experienced. At other times, they may have conflicting, almost opposite sensations from what we're experiencing. And this is key to understanding how art appreciation happens. And this is key to understanding why anything that we perceive causes this complex set of behaviors in us. Because even if it's not art, anything that we experience, these either conflicting or cooperating types of neural states, right? And neural state is basically an emotion or a thought. So these conflicting or cooperating neural states have to resolve themselves. And that's kind of what we're doing when we're it's not a cognitive, when we're realizing, like when the first few seconds after you see something happen, your brain is kind of converging into a single predominant notion of what happened. And that notion may be a thought, it may be an emotion, it may be both. Now, when you get into, and then there's interpretation. So the question you asked has to do also with interpretation and memory. So after you have a notion of what you just experienced, if it's a musical note, let's say that you heard a siren go off, or a police siren, or an ambulance siren, right? And you can't, and for some of us, we can tell the difference between an ambulance siren and a police siren, right? But in the initial processing, you wouldn't know the difference. You'd only know that there's a siren, there's some type of sound which has grabbed your attention. You need to pay attention. Your mind will start to realize it has to stop doing other things because there's something really important that it's being signaled with. The siren is a signal, and your brain kind of initially realizes it has to stop processing of other things, start paying attention to the siren. And then your brain goes back into its memory and starts to figure out if that siren matches the memory that you have. Is it a police siren? Is it an ambulance siren? Which type of siren is it? And if you're driving, then you're going to take action based on that, right? Because when you hear a siren, you're supposed to take immediate action when you're driving. So depending on what you're doing, and depending on the types of memories that you have and how strong they are, they will impact the sensations that you have. They'll cause you to stop using some of your senses. They'll cause you to focus other senses. They'll cause some senses to be less dull. So for example, another example, this is an example I gave months ago, where the sensation of, actually, this is a little different. I was going to talk about sneeze, but let's say that you hear, that instead of you sneezing, you hear someone sneeze. Okay, well, most of us, if we've been trained, socialized, after we hear someone sneeze, there's this automatic reaction to say, God bless you, or Gesundheit, or just respond in some way, because socialization has taught us to do that. That happens at a below perceptual level because our automatic systems have learned through years and years of training that when you hear this automatic sound, which sounds like a sneeze, you automatically activate your vocal center of your brain, which causes you to think of the idea to say something, but not just to say something, say a specific thing, God bless you, or, and then that causes additional cascades of behavior, which ultimately gets your mouth to move, and then you actually say the words. So the sensations that we experience can cause suppression of memory. They can cause evoking of memory. This is no longer just about art. This is about how we process any kind of information that we get from the outside world and what it causes in our brain. And art is a subset of that, because art deals with positive and negative emotions mostly, or confusion, or certain types of emotions. But there are many all of the types of things that we can experience in the world are beyond just artistic experiences. So hopefully this answers what you're asking.
All right, Sanjay, there are a whole bunch of questions for you. So I would, I love your answers, but let's try to keep it shorter so that we can cover as much ground as possible. It's going to be Liz, Ed, Franklin, Joy, David, and Mike next. Liz, go ahead.
Thank you. Sanjay, the very last slide that you showed on your PowerPoint presentation, the very last line, in fact, had to do with the 25% of people having 4, was it cones, color cones?
Yes.
I'm just mind blown by that, because you said that people who have it can't explain. You said something about them not being able to explain someone who only has 2 or 3, what that looks like. How does someone know that they have 4 as opposed to the normal 3? I don't get it.
We cannot know, because this is one of those where if you're, and this applies to every aspect of our physiology. If we're born with something different in our body, it's for us to know. The only way we can know is by comparing with others. And when we're talking about experience stimuli, for example, visual stimuli, it's not something like, rarely do we talk to each other about the experiences that we get out of hearing music. I mean, we might describe a music, a song that we hear. We might describe it in very vague terms, or even, if you're talking to another musician, you're a musician, you may describe them in very specific senses. But the level that it evokes stimuli within your mind, that's very difficult to communicate to another person. Okay? But what does happen is that what we've noticed is that there's a greater prevalence among certain communities. For example, visual artists, there's a greater prevalence of them having 4 cones than not. Okay? So this actually does affect our life choices, because what may be happening is that somebody who has 4 cones has a much richer experience of the visual world. And that makes them become more visually artistic. And that's what they prefer. And maybe it becomes either a hobby or a profession for them.
Thank you.
All the senses, not just visual. There's dynamic differences in perceptual ability in all of our senses. So they're super tasters, you may have heard of. They're hired by companies, food manufacturers all the time. Similar things across all of our senses.
Thank you. Next up is Ed.
Yeah. Hey, Sanjay. Very interesting. I wanted to ask you about, in reference to the taste buds, an important component for many people, especially those that come from Indian, Chinese backgrounds, Mexican, is the concept of pain in our perception of taste. There is an enjoyment that people get from the pain that certain things like chili and peppercorns give us. And that's present in a number of people, and it's in others, it's not tolerable. And how is that really developed?
Yeah, so that, so I'm gonna have to speculate, because this isn't something that I've learned much about, but I understand other areas of biology, other areas of sensation that I understand. I can explain. I'll use that to explain this. So pain is not something that's associated with taste or food or gustation, but when we're talking about food, in terms of prehistory and historical times, the preservation of food was very important, right? And throughout antiquity, we didn't have refrigeration. We didn't have many ways of preserving food. We humans came up with many techniques, for example, salting or brining, etc. And actually, the spices, what we call spices, but spices actually are gamma. What you're talking about is the hot spices, the Scoville scale related spices, right? Those also have been used to kind of act as a disinfectant for food, because Scoville scale peppers disinfect. Okay, they actually kill off bacteria, just like they cause pain. They actually kill off bacteria and certain germs. So mixing that in with food allows us to preserve food for longer periods. And that's probably the reason why this came about in human history, because it was a method without having refrigeration. It was and without putting tons of salt into foods, it was a method to allow food to be preserved for longer periods. And then, because we had to eat that food, we developed this sense of familiarity with it. But it's still painful to everybody. And then there's this sociological aspect where people, feel proud to be able to eat, the hottest chili pepper they can. That's more a sociological element of it. It's not perceptual.
Thank you. Next up is going to be Franklin and Joy. Franklin.
Hi, I wonder if you could say anything about synesthesia, where we can hear what we see or taste what we hear, where the senses become fused in the head or somewhere.
Yeah, excellent. Yeah. So synesthesia, for those of you that don't know, is when you might be able to taste music, or you might be able to see pain. Like if you experience pain, it might actually cause blotches in your visual system. You might see shapes or colors in your visual system corresponding to pain that you've experienced in your body. There are some people who who've been studied, when they read numbers, specific numbers, those numbers always have colors associated with them. And what's interesting is that the patterns of the numbers, for example, if you take the number 5, which has a red, in their case, and it's the colors vary, it can be arbitrary, there's no pattern to it, but for one person, if the number 5 denotes a reddish color to them, and the number 2 denotes a bluish color to them, then believe it or not, 5 times 2, which is 10, the number 10 would denote a reddish bluish, which means purple, a purplish tint to them. And actually it follows at least the people that have been studied, seems to follow in a mathematical sense. Similarly with music. So with synesthesia, what's happening is that the first level of processing happens in the way that it normally does in every person. But then after that, the information that we received, which is called transductance. So basically, the sensory perception is only the energy that gets converted from the outside world, for example, photons for light, or airwaves, or vibrational molecular vibration for hearing, similar for pressure and things. So that energy, once it gets carried through our perceptual system, after it becomes converted into energy that's electrical, that starts to enter neurons, that's the point at which I'm talking about. That's the point at which that's called transduction. And that's the point at which you can start to have these effects called synesthesia. Okay? And synesthesia basically is where, for example, your hearing would primarily enter into your temporal region. That's primarily where it enters. And the visual system primarily enters into your occipital region, the back of your head, back of your brain. But in people with synesthesia, these concepts of the sensation quickly bleeds into other areas of the brain, quickly moves into other areas of the brain. It may be that it's hard to understand why. We don't really know why it happens. It may be that the myelinated pathways in their brain form these highways connecting these other regions at a young age, or it may be they're only connected regions between certain areas. For example, synesthete might only have auditory sensations. Others have across many of the senses. So, these are elements of it. And I can go more, but I want to get to other questions.
Thank you. Next up is going to be Joy, David, and Mike. Joy. Joy, you need to unmute yourself.
Yes, I'm doing it. Sanjay, you see that the brain is constantly expanding as one of those organs that is really, really dramatic. And you talked about how the cells are constantly renewing. So with the renewal of the cells in our body, do our senses actually change? And it goes back to that nature versus nurture kind of question.
So actually in our brain, our brain is a unique organ. It's separated from the rest of our body. We have this thing called a blood-brain barrier. But our most of the cells in our brain, especially the neurons, don't regenerate. So if they die, they're gone. What does happen, what can happen, is that we can grow new neurons or new other types of brain cells. So they don't, if you lose a neuron or if you lose a cluster of neurons, they don't repair, they don't grow back. So unfortunately, that's one of the reasons why after a stroke, somebody who's had a stroke, it's very difficult to help them. What actually happens when they're going through physical therapy or to try to, they're retraining their brain to take over those lost functions from other neurons that are neighboring regions. They're retraining other neighboring regions. And also it may happen that because of this retraining activity, there's certain types of enzymes and hormones that are released, and this happens throughout our body and everywhere, that cause growth. They're growth factors, cellular growth factors. And there are cellular growth factors in the brain which cause nerve cells to grow. So it's possible that after certain types of trauma and loss, that we have a very slight amount of these growth factors that are released in certain regions of our brain that do cause new neurons to grow, but it's not sufficient to rebuild what's been lost.
All right, so two more quick questions, and then we'll go, we'll probably, let's figure out what to do afterwards. So it's going to be David followed by Mike. David.
Okay, hi Sanjay. So you spoke about hearing sounds, and it's interesting what you said, looking at it as a processing system. But I want to point out a different sort of point of view on it and ask you how you look at this, because we're going to be talking about, I think, art and the human experience. So we're talking about the human experience, what you have awareness of or can have awareness of. So according to Heidegger, when you hear the fire siren, you don't hear a noise and interpret it as a fire. You hear a fire hydrant before you think about anything. In fact, if you're asked later, what did it sound like? It is an uncanny feeling because you have to delve into, you may not even know what it sounds like. You've never figured out what it sounds like and parsed what it sounds like. So there's some immediacy to the way things present themselves to you in first experience, in raw experience. And then you're interpreting them and running out of the room or whatever you do without even knowing what it sounds like. Okay, there's a different thing because that's an abstraction sort of from your experience. But looking at me as a robot or a mechanism, you can look at neurons and see chains of reactions and say, well, it went to this processing and that processing. So you must have had a pure noise and then an interpretation of something. But that's not like the human part of the experience. So there's a sort of your body and awareness of it. So body view of what happens, looking at the body as something to dissect, and there's an awareness view of the experience. So I'm saying we're looking at time in two different ways. My time consciousness of the alarm is a certain way, and the dissecting the frog way of looking at what happened is a different way. And I'm saying, which of these can you apply when you're looking at art as an experience? You know, there's kind of, it's about the subjective experiential part, which you actually, that part of your mind is not so much a dissected part, or how do you see those two playing together to talk about art?
Right. So, yeah, I mean, what you're raising is perception. How much of it is the physiological element of neurons and electrical impulses firing, and how much of it is this awareness, this consciousness that we perceive. And that's something that, you know, in future talks I will go into, because that's something that's really interesting for me. And I think it's important for everyone to understand. Though it's premature for us to go into that right now. But what I can say is that the way you describe the awareness of that sound that you heard for the first time, right? You don't have any memory of that siren. You heard it for the first time. That sound we had an awareness of after the fact, but you have to remember that our brain is the one that's making the awareness. Well, I'm making an assumption here. I'm making an assumption that awareness is in our brain. It's not somewhere outside. It's not in the quantum state of matter, or for example, because if it was, it wouldn't be explainable. It would pose other problems for us in the sciences. But when we experience something, anything for the first time, and even subsequently, the experience is something that happens at a moment, and then there's an awareness of it that happens at a future time. Okay, that awareness always follows it. It's never simultaneous or before. That's something that's important to understand. Is awareness always follows, and the awareness, from what we understand right now, the awareness happens in our frontal lobe. Most people think it's in the prefrontal cortex. So, and that part of the brain gets activated usually one of the last in any kind of stimuli that we receive. So I know that's not answering your question, but we'll go into this more later.
Okay, last question is from Mike. Mike, what's your question?
Would you say that the psychological emotions that give art quality come from a successful closure or convergence, which we find comforting? The human mind is a pattern matching machine. So when we unconsciously match, for example, the Fibonacci sequence in The Last Supper or Mona Lisa, is that why we say it's good art? Because even unconsciously, because all our lives we've seen that in leaves and seashell, and in that background you got behind you of a floral pattern.
So what we perceive as pleasing and what I mean, when you asked the question, I mean, you phrased it in a way that I'd agree with, that our brain is resolving, it's not always conflict, but it's resolving and trying to come to a consensus with many sensations, many feelings and emotions and thoughts that we're having, that the piece of art evokes in us. And it's not only art, anything in the world that happens, same thing happens, but art tends to deal with positive and negative in a simple way. Emotions around positivity and negativity. So when we're actually, one of the things that you said is that art, I think you said that art is trying to resolve all of these sensations into a positive feeling. I don't agree with that. I don't think that art always has to leave us with a positive feeling. Art just has to leave us with something. It can be a thought, it can be a feeling, it can be our own perception, it can be a confusion. Actually, some art, it's okay to leave us in a confused state because that's the intent of that art piece. But it will leave us in a certain state of mind. That's the whole point of what art is, I believe, what art is about. So it's not always that it'll leave us in a positive state. For example, there's I forget the artist, just a few years ago, he put a piece of banana, taped a piece of banana using a duct tape on a wall, right? And most people who saw it were shocked. How could that be art? Okay? And then there was a subsequent performance art, where another artist who unannounced, because this art piece was not protected, it was just taped on the wall in a gallery. And this other artist, unrelated to the first, went there, peeled off the banana from the wall and ate the banana. And that second artist said, "This is my performance art." Okay. And in a sense, yes, that was performance art because he performed, he did something. He so-called destroyed the previous art by eating it. But actually, if you understand the way the art world works, he didn't destroy the first piece of art, because the first piece of art was not about the banana and the tape. It was about the right to display a banana and a tape in that configuration. Okay. And so the gallery could immediately take another banana and another piece of tape and just put them in the same orientation again, and the art piece would be back the way it was. So this is an element of art where the thinking mind comes into play, because especially art, modern art and contemporary art and postmodernist art, a lot of these types of art deal with thinking. They no longer deal only with our perception. They deal more with the thinking side of things. And that's an element that I don't know if we're going to be able to get to tonight, but I want everyone to understand that this is the reason what makes art so complicated. This is the reason why most of the more recent forms of art are so controversial, because they require thinking and they require conflict. And the artist oftentimes wants to create that conflict in the viewer or in the person experiencing it. Good. Okay, let me do that. What I'd like to do is go into, so just, we talked about, we're looking at vision primarily because that's an easier one to understand for everyone. So I want to give, so what we saw was that our eyes have different frequencies or prevalence of color receptors, right? Red being the most dominant, most frequent. So what I want to do is I want to look at other ways that we can see how color comes into play. And color is one of those things in art. It's one of the most visible things, most striking things in art. That's why I'm picking color as a starting point. So if we look at anthropology, all human languages, all cultures give importance to color. Right? And there's a certain pattern that we find throughout human diversity, human diaspora. So most human languages and cultures have a symbol, which means a word for the two main colors. Okay? And these aren't really colors, but we call them colors, white and black. Pretty much every language has this. Now, of the languages that have 3 colors and only 3 colors, the third color is always red. Okay? And that's not surprising because red is the most likely color receptor in our eye. Okay? The next of the languages that have 4 and 5 colors, the next 2 are green and yellow. And sometimes they vary. Some languages have yellow as the 4th. Some languages have green. Green is usually the 4th. But these are interchanged. And that's, again, related to our visual system, because the green color receptor is the next most probable. And green color receptor actually detects green and yellow and orange. Okay? It's a wider band. Next one is blue. Okay? Of the languages that have 6 colors in them, okay, the first one is always white and black, then red, then green, yellow, and then blue. Okay? This pattern continues, 7 brown, and then and anthropologists have looked at 11 colors. And this pattern repeats in every single human language. Okay, this is pretty remarkable. This always is the pattern that they've seen. Okay, that shocked me when I first learned about this. What this says is that there are 11 basic colors, and these basic colors probably are somehow tied to our biology or our evolution. Okay, because every human being, independent of where on the planet we grow up, or how long ago our culture existed, or any aspect, whether we live in an Arctic tundra where there's no green leaves, or we live in a lush green forest, green is still number 4 and 5. Okay? And that's remarkable. So probably there's evolutionary and biological forces that drove this pattern in us, in our color perception. And if you understand this sequence of color, and if you're an artist, and you understand that red has very strong signal in our brain, and green and yellow have the next strongest, and gray has very weak signal, then you can use that in your art. Okay, and actually, when you start to interpret art forms, you'll find that red is an important color in many art. And this talk, I won't go into a lot of other areas, but for example, one of the things that we know, I have slides that we're not going to go to, but in art appreciation, one of the concepts in visual art is, you look at the gaze of the viewer. Where does their eye fall first on a painting? And then where does it move to next and next and next, right? There's a pattern that when you look at a painting, there's a pattern that your eye takes from the initial part to the next, etc. And then you have a realization of the entire scene, okay? And that pattern follows a certain pattern across most people. So depending on the art piece, especially the most famous art pieces, that sequence of gazing actually has a fixed pattern that seems to follow in most people. Okay? And it follows around the concepts of color, concepts of faces. So if they're faces, because our brain picks up on faces very quickly. There's a region of our brain which picks up on that. Texture, lines, the many aspects. So this aspect of how our eye follows an art piece is actually very important, but that's also driven, it seems, by these evolutionary and biological aspects of our perception. So talking about art, the art world defines 7 elements of art. Okay? Lines, shapes, forms, spaces, textures, values, and colors. Okay? And not in any necessary order, but roughly lines are usually the first. And the reason why I'm bringing this up is because, at least in the visual arts, these 7 things, and there may be 8, there may be 9, but these 7 primary things are always the elements that art relies on. And also there's the negatives. Each of these have negatives. For example, the negative of space, the lack of space. So in art, there's a concept of what's outside of the frame, okay? Or a painting has painting elements, but then there's the canvas. Is that canvas considered negative space or not? Okay, these are concepts in art that have both a visual perception, but they also have a cognitive perception in art, at least in art interpretation. So these 7. Now there's another view here, okay, and there's 14, and the first 7 in this table are the same as the first block. On the right side, we have 7 additional ones: balance, contrast, emphasis, movement, pattern, rhythm, unity. Now we combine these 14, and it may be 15, it may be 16, it may be 12 or 13. The exact number doesn't matter, but roughly these types of concepts apply to all art forms, not just visual art. Okay? The concept of emphasis, the concept of movement, concept of pattern, these apply to music, these apply to culinary art, these apply to every type of art that we have. The 7 on the right apply to all types of art, and the reason is because the first 7 on the left, there's a mistake there. First 7 on the left deal with individual features. Okay? They deal with individual features of our perception, and they are acting in the sensory parts of our brain. Okay? And the next 7 are dealing with interactions among features. Okay? Interactions among the left 7. And these occur in the deeper regions of our brain, and these occur among the multiple regions of our brain and the interactions. So for example, contrast. Contrast, not only in a visual or perceptual sense, but contrast in a cognitive sense, where you have a contrast between the fear and a love, right? Where you might see a painting that shows an infant, a baby, but then you might see the babies in a scary situation, and that evokes both a feeling of love and a feeling of fear, and that's the contrast. Not a visual, but that's emotional contrast. So these are elements, so this is how the art world looks at it. Now we're going to look at things in a very different. There's an analog I want to bring about, and this is with artificial intelligence, especially with artificial vision systems. There's a lot of research, and the visual perception that artificial intelligence systems are doing, they're based on our visual processing systems in a rough way, but interestingly enough, they were not developed to mimic exactly what our brain does. And I'm talking mainly about neural networks. Now, what neural networks are they're basically a sequence of this diagram. There are 8 different stages. This leftmost is one stage, then there's another stage, etc. So in this diagram, there's 8 stages of visual processing of any image that happens in a neural network. Okay, and these different stages are not programmed. These stages are automatically created. The neural network learns to do each of these stages on its own as it experiences different visual stimuli in the world. Okay, so you have to train a neural network, for example. As we train neural networks, they learn how to formulate and organize each of these 8 stages. And the number 8 is arbitrary. It can be 6, it can be 19, it can be whatever number of stages that will determine the complexity of your processing. Now, what we find is that, and this is another example of the 8 stages, or in this case, there's 7 stages, where you start off with an image on the leftmost side, and that image goes through the first stage of processing in our brain. Now, all of these stages of processing in our brain, processing in a neural network, actually, these have very exact parallels in our brain. Our brain does something very, very similar, interestingly enough. And these neural networks were not designed around our brain. It just so happens that the way that they do processing is very similar to how our brain does processing. Okay? So these next 2 slides are going to show, so the leftmost side here shows layer 1 of the processing. What that's doing is it's trying to find basically straight lines in an image. So remember when we talked about the 7 elements of art, and line was the first element, our brain actually does this. Our brain looks, when we first perceive something visually, the earliest area of our brain is looking only for lines, okay? And it might use color to differentiate lines, it might use contrast, but it's only looking for lines. The next layer is looking for something slightly more advanced than a line, what we might call an arc, okay, or a curve. Okay? And then the next layer may be looking at patterns, okay? Complex patterns. It may be a checkerboard pattern, or it might be but each of the successive layers of processing get more and more complicated. And so what we have learned is that processing of vision occurs in stages, and this is true in our brain, that our visual system and basically many of our sensory modalities process things in stages, but our visual system has been studied very much, and we understand a lot more of it. And it follows, so there are visual areas in the occipital lobe, in the visual cortex. They're numbered V1 through 6, and there's actually V7 and 8 also, which are very much analogous to what I showed you with neural networks, with artificial neural networks in computers. They're very, very similar to what our brain is actually doing. And it's not that those systems are modeled on our brain. Those systems, those aspects of visual processing are not modeled on our brain. They just happen to do it the same way. And this may be because this is an efficient way for it to work. This is maybe why our visual system developed through evolution, because this may be an efficient way to break down scene that's in front of us, to break it down into these simple elements of lines and shapes and arcs and color and regions and patterns and texture, etc. And you build up into more and more complex objects. You recognize, oh, this is an apple. First, you see it as an arc, or roundish type of shape. And then you see that there's a texture to it, and then you see the color of that apple. And then you see there are elements of the apple that don't match. For example, there might be a stem and some 2 leaves on it. But then after you put it all together, the more later stages of the visual processing puts all of it together and recognizes it as an apple. So we have a fuse of one face area, so this recognizes the face. We have, so information moves from, and then the information that goes through the primary processing, let's say a vision. Once we have an understanding of the scene that we're looking at, that there's an apple in this scene, that information that moves gets transferred through these highways, information highways inside our brain to other lobes, to the temporal lobe, to the mesolimbic lobe, and finally to the frontal lobe. And they do move in sequence. The frontal lobe, the thinking part of our brain, actually gets a lot of this information last. This is, we've talked about this in previous talks. So there's low-level recognition occurs in the occipital lobes, and then there's feelings arise in temporal lobes, and then there's an understanding, which usually means thoughts. They arise in, that should be the frontal lobe. That's a typo. So understanding arrives in the frontal lobe last. So what I'd like to do is, so that's all I have right now for our talk. What I'd like to do is we can do either question and answer, or I have an example of a painting that I think we can look at, try to understand what actually happens in our brain when we look at a famous painting.
Let us do one thing. Let us give a chance for people to ask some questions, and then we will take a break in the middle and do the painting. Folks, if you have questions, go ahead and type exclamation mark in chat. If not, we're going to go with the painting. So here's your chance. I'm going to give you whole 20 seconds to type exclamation mark. Manny, did you have a question? Okay. All right. Let's go ahead. Let's go ahead with the painting. Looks like everybody. Okay. Barry has a question. Barry, go ahead. Folks, if you have questions, go ahead and type exclamation mark.
Sanjay, my main question is, I read a book, and I have a picture of that book behind me next to my painting. It's by a woman by the name of Barrett, a neurobiologist. And she says she has come up with a theory that we manufacture our own emotions, and that emotions are really configurations of neurons in the brain. And so as a consequence, we can create our own emotions. And so as an artist, I have learned I can engineer my emotions based on this theory. And I wanted to know what your thoughts were about this concept of being able to create your own emotions. Thank you.
Yeah, excellent question. So I do agree with that. It's when I refer to emotions or thoughts, and emotions and thoughts are indistinguishable from the point of view of neuroscience, I call it a state. So you called it a configuration of neurons, but it's a state of neurons. And same thing. It's just different terminology that I use. So a configuration of neurons is one way to describe a distinct specific emotion or thought. And as far as us creating emotions, that's a little more challenging to explain. Yes, we do create emotions in the sense that emotions arise from multiple processes that are happening inside of our brain. And our brain is us, right? So all of the things that are happening inside of our brain work together to create the next state and process or configuration of our neurons. So the current state that my brain is in, or your brain, or any of our brains is in, goes to create the next stage that it will be in. So if I'm feeling happy right now, or if I'm feeling surprised right now, then that feeling will influence the next emotion or thought or both that I have. So in that sense, we do create it. Our brain is creating our future perceptions also. Perception is tied into this because remember, perception is based on our memory and based on our current state. So it's very dynamic. It's hard to explain, but yeah, I totally agree with what you described her saying.
Kevin is next.
I got a quick question, Sanjay, about our mind feeling. A feeling is stored local, whereas some on the chat say the mind is non-localized awareness. Is mind is stored on neuron or outside? Thank you.
Okay, so yes, we're going into a little bit of consciousness and where exactly is consciousness. I mean, the things that we're talking about tonight, all of these things are definitely in our mind, and they are very easily measured. They're very easily determined, except for the perception part of it. Except for the transductance, where we have an awareness and the emotional interpretation of art. That part is more cognitive. And that's the part where, I'm going to assume that that's the part you're talking about. It's very difficult to talk about that without having an understanding of what awareness is. We haven't really talked much about it. We had a very rough introductory talk about it a few months ago. And I will do another talk on that. But awareness is very important to understand. These are the subsequent aspects of art. Art creates an awareness in us. Eventually, after a few milliseconds to a few seconds after we've seen something. And that awareness is much more complicated than simply saying that it's, I'm trying to think of the simplest way to explain it. You described it as it being in our neurons. So that's something that I have to correct, because our mind is not in one neuron or a small group of neurons. Our mind is in all of our neurons together simultaneously. Okay? It's not that one or a clump of neurons or a region of our brain makes us behave in certain ways. It's not that way. Our entire brain has to work together to give us the full experience that we have. And if a significant part of our brain is not working correctly, there will be deficits, there will be losses in our abilities. We might not even behave humanly. So that's important to understand, that it's not simply neurons, it's the interconnection of neurons. It's a dynamic changing of states between neurons that gives us everything that our brain does. It's not simply the neurons.
Wonderful. So let's go to the painting now. Okay, let me do one thing. Before we go, I want to tell you about some incredible meetups, many of which are connected to art, that are coming up this weekend. Okay, let's see here. At 12 o'clock, we're going to be talking about comfort of cuteness. Brian McQuay is going to be back. He's spent 17 years in Japan, and he's written several books on Japan. So he's going to be talking about how Japan uses cuteness. So it's going to be about cuteness and power, aesthetics of power. So that's at 12 o'clock. At 2:30, we're going to be talking about Louis Sullivan and his concept of art. At 5 o'clock on Saturday, Yasuhiko Kimura is going to be back, and the theme is going to be inner freedom and outer freedom. And we are going to go through Buddhist thinking, Indian thinking, founding fathers, Spinoza. It's going to be a wide-ranging discussion on that theme. On Sunday, we are going to be talking about the inner senses. What are the inner senses we have? There's a concept of common sense that the medievals have, which are kind of combination of senses forming perceptual experiences, and then other senses that we have, like memory and imagination, and senses that we put together. This is based on theory of Thomas Aquinas and Dr. Mark Parker, who is an expert on Thomas Aquinas. He'll be there talking about psychology of Thomas Aquinas. That's going to be at 2:30 on Sunday. At 5 o'clock on Sunday, we're going to be talking about active imagination in Carl Jung, of how you can use your creativity to discover yourself. So that's what is coming up on the weekend. Over to you, Sanjay.
Yeah, that's a lot of confluence of very important ideas.
Thank you.
So let me share my screen. I'm trying to. So we're going to basically be looking at a painting by Monet. It's called A Bar at the Folies Bergère, which is, let me see. So this is the painting that we're talking about. Okay. And it's a fairly well-known painting in the art world. And it's significant because this painting actually changed the direction that art went in the late 1800s. This painting was painted in 1882 by Monet. He actually died the following year. So there's a lot in this painting that are obvious. And then once you look at the painting, you start to realize things aren't so normal. Okay. So obviously there's this woman who seems to be a young woman standing in front of us. The title tells us this is a bar scene. And behind her, what appears to be maybe crowds of people. But we see in the painting that those crowds of people aren't very distinct. They're kind of hard to see. And if you look carefully toward her hands, you'll see at the bottom, near the countertop, the wall seems to have this reddish tint, and there's a gold frame around something. And that kind of suggests that what's behind her may actually be a mirror. We're actually seeing mirror behind her. And then we look in the painting and we see to the right of her another woman in the back. And then we realize, oh, that may be her reflection in the mirror, right? So these are kind of the things that may happen in a lot of people when they see this painting. Not necessarily in that order, but they'll see the woman first because our visual system is key primed toward looking at faces. And of all the faces, of all the heads in the painting, her face is the most visible and prominent. So we'll see that first. We'll see the type of clothing that she's wearing. Then we might see, the background and the foreground that there's this brightly orange colored fruit, probably tangerines or some type of orange. There's green bottle, several types of bottles in front. So what's happening here is that, and I'm going to talk at the perceptual level first, and then we're going to go deeper into the cognitive level. So at the perceptual level, our brain only sees the colors and the lines and the faces and the primitive elements of this painting. Okay. The fact that her face is there, that's a primitive element. Then we see the lines of the buttons down her front. That's a vertical line. And then on her neck, there is the two lines formed by her dress, right? Her arms seem to form straight lines. There are horizontal lines, several horizontal lines. One is from the countertop itself of the bar. The horizontal lines behind her in later on what we realize are reflection. And then we see these bottles have somewhat a vertical pose, right? And that's at the first level. Then we start to see arcs and certain shapes. So again, her dress has these curvatures. And then we see that there's a chandelier in the background that has curvatures. And we see this glass type, it's not a vase, but it's a container that's holding the oranges. It has a curved shape to it. The bottles have curvatures around them. The reflection is curvature. And our mind, our brain senses all of these. And at that level, it doesn't know what we're seeing. It hasn't figured out that this is a painting of a woman. This is long before our brain even senses that. Our brain is simply seeing these lines are there. There's a curve of a necklace, what later on we realize is a necklace. Because to recognize a necklace, you have to have a concept of a necklace in your memory, right? And you have to bring out that conscious of a necklace in our memory. So one of the things that happens in when we look at art, and actually this happens in everything, is that when we look at something that we recognize, okay, recognition in memory is very important in the neurosciences because one of the neurotransmitters, dopamine, is released whenever we successfully recognize something. Dopamine gets released when we successfully recognize. So when we recognize that she's wearing a necklace, we actually get a hit of dopamine, which gives us a pleasure sensation. Okay? When we recognize her face, we get a large dopamine rush. When we recognize that she's a human being, we get another large dopamine rush. So our brain has evolved and our brain exists in a state, it wants to recognize things. It's going through a lot of mental activity, try to figure things out. It's got this strange scene of all these colors and shapes and patterns in front of it. And it really doesn't know at the beginning what it is. is trying to figure out what it is. And the first thing it does is it tries to find all the lines, and it finds to find all the curves and shapes, and then it tries to find the colors, and then it tries to find the texture. And it sees the texture of the dress that she's wearing seems to evoke like a velvety type of texture, like kind of, it's a dark color, dark blue color. And the texture in the background is these faces we can't recognize, but we can kind of tell by the shapes that they're people. So all of these things are happening in us. And then after we realize that she's a person, after our visual system has recognized there's a person in the scene and their fruits and their bottles, and possibly we might even recognize their mirror. But for some people, they may not recognize there is a mirror. They may recognize that later, right after they see a reflection. And there's a conflict in their mind that there's a woman that's facing away and there's another woman that's facing toward us. Yet their dresses are very similar and their hair color seems to be similar. Maybe it's the same woman. That conflict will get them to figure out why is the painting this way? And they might have an idea that it's because there's a mirror behind her. And then they might look for other clues, or the brain may have picked up that gold bar at the bottom, right? Which usually, in the 1800s, large mirrors had gold trim around them, or some fancy trim around them. And Manet painted this in the 1880s. So he used the language of that time. Okay? The language of the time also, there are many things. So someone who would have seen this painting at that time would have seen something very different than what we're seeing today. What we're seeing today, the appreciation we have today is very different from that time, because a lot of time people may not realize this, that when he painted this was a scene in Paris. And the Folies Bergère was a very famous, very large type of entertainment venue, which had bars. The closest analogy I can use is what Las Vegas is like to us. Okay? It's kind of a place where anything and everything goes. Okay, and Manet chose this scene because it was very indicative of transformations in Parisian society at the time and in culture around the world at the time. Now, what I'm getting at now is I'm getting at the intellectual part of this art piece, right? That if you understand the history, or if you understand these aspects, if you have the memory of an understanding of these, that will help you to understand what you're seeing. Okay? For example, in the top left corner of this painting, if you look carefully, you're going to see two little legs. They're tiny with green shoes. I don't know if everyone can see that. Okay, that's kind of odd, right, to see in a painting, but your visual system will pick up on it. Okay, it might not pick up on it first thing, but after a few seconds or probably a few minutes, your visual system, because your eye is always scanning continuously everything. It wants to know everything, because part of our visual system also is there to detect threats. Our mind doesn't know if we're looking at a painting or if we're looking at the real world in front of us. So it's trying to detect threats. So it will eventually find those two legs dangling in the corner. Okay? And that doesn't make sense. Okay? Why would the artist put those two legs dangling, and why would and those legs seem to be women's legs? Okay? Why would they be hanging from the sky? That's odd, right? Another thing that we're realizing is that we're looking at this painting at the woman, and once we realize that there's a reflection of the painting, we see this man's face being reflected in the painting, yet the man is not there in the painting, right? And the perspective we have of this painting is that where we're standing is where that man should be. He should be in front of us, the painting, but he's not. So the man's reflection is shown, but the man himself is not shown in the painting. And that creates this discord, right? This contrast at the beginning, but once it becomes deeper in our mind, it creates this deep question, confusion, and it may even be uneasiness. Why did the painter do this? Or why can't we see the man when we can see his reflection? Another thing we may realize is that the angles don't match, right? Because if the man is reflected at that angle on the woman, okay, that doesn't match what we're seeing in the mirror, right? Where we're standing, the woman's reflection should not be off to her side. It should be directly behind her, right? So there's a lot of visual incongruities that Manet has put into this painting because intentionally he wants to subvert our sense of reality. He's no longer using realism. For those of you who know, he used impressionist styles. This painting doesn't have a lot of impressionist styles that other painters did, but he's using some of the thinking parts of impressionism, which made us question things and question reality and question. So one of the things about this painting that's unique that somebody looking at it today will not understand, probably not understand unless they've heard about this, is that at this time period, women were basically, prior to this time period, women only stayed in their house. Women did not go to work. Women did not go outside the house other than with a man. And yes, it was very provincial and very sexist, but that's the way the world was back then. And when Manet painted it, he understood that, and he knew that. And what he was putting in this painting is a woman who's working. Obviously, this is her job. She's at a bar, she's working. Okay? But this concept of a working woman was kind of ambiguous in those times, okay? Because one of the things that is not obvious here, but to people who lived at that time period, the Folie Bergère was also a place where prostitution happened. And some of the people who worked there could have been, not always, and usually they were not, but some of them could have been a prostitute. So what Manet is doing here is he's hinting at us that the man, is he simply a patron, a person who went to the bar to buy a drink? Or is he a person who's interacting with this woman? And why is he interacting? Why is he hidden? And the reflection, is that a reflection of reality, or is that a reflection of the woman imagining something? Is that a reflection, an imagination of something she's thinking? Because if you look at the face of the woman, her face really doesn't convey emotion to us. It's actually very confusing, right? It kind of has this almost bored type of look about it, right? And so if she's supposed to be selling goods to a patron who just walked in front of her, and she has this bored look, that may not be the best thing. So that gives us an understanding that maybe what Manet is doing is he's not telling us exactly what's happening in real time, but this may be conveying memories in the woman. The woman, the legs in the left side, left corner, they had acrobatic acts in this very large cavernous hall. It was a multi-story building, and they actually had acrobatic acts. So those legs are another probably woman who is doing acrobatics. So this shows the elements of the scene that we're seeing. So these are all examples of, a painting which at first glance, when you see it, it really looks to be a very simple scene. But when you start to think about the things in the painting, and does it make sense? And the reason why I chose this painting is because this was one of the earlier periods where famous painters began to play with the concept of reality. And they began shedding the concept of art needing to portray reality in realistic ways. Right? Painters prior to that predominantly portrayed reality, but here's where we have a painting which is no longer portraying reality, but in a sense it is. The superficial level, it seems to show reality, but once you start thinking about it, it doesn't. So I'll stop here for now. I mean, we can go on. I can talk more about it. There's actually another sculpture that I wanted to talk about just briefly. I don't have a picture of it here, but it's a sculpture. It's a three-dimensional sculpture. It's roughly 30 feet high. Okay? And there are, I believe, 7 or 8 versions of it made by the artist, Louise Bourgeois, I think is her name. And she made, the sculpture basically is a sculpture of a spider. Okay? And it's a spider that looks very threatening. But what's interesting is the spider has a sack of eggs. So you can tell it's a female spider. And she made this sculpture, and everyone who looks at the sculpture sees the sculpture as threatening, because in our visual system, animals like spiders evoke fear in us. That's natural in us. Okay? And she understood this. And she made it extra large. She made it gigantic. Okay? But she made it a female spider. And other elements of her sculpture, once you start to think about and understand it, will tell you that the artist, the sculptor, her understanding of her mother, she saw her mother as a spider. And she saw spiders as good things, as positive things, not as negative things. So once you understand this, then we, the viewer of this art piece, start to understand, it's almost like it removes a layer of fear from seeing it as a spider versus seeing it as a person or seeing it as her mother, right? And all of a sudden that art piece takes on another dimension of a female woman, who happens to be a spider, but it has this sense of motherhood about her. And then it's no longer about a menacing spider. It's about a mothering spider who's taking care of her babies. And that's an example of art, which, using the different parts of our mind, the visual system versus the cognitive system, we can have different appreciations of art at different levels.
Wonderful. Thank you, Sanjay. So folks, now if you have any quick, do you want to stop sharing the screen? If anybody has any quick comments, takeaways, you're welcome to do that. It's getting late, so let's try to keep it brief. What did you guys get from this presentation? Just go ahead and type exclamation mark to share your takeaways, brief takeaways. All right, Joe, go ahead. Let me see if I have, give me a second. Okay, I think, all right, sorry about that. Go ahead.
No, I just wanted to say thank you to Sanjay. Actually, I thought he did a really good job with connecting memory and the importance and the appreciation of art for me in particular. So, and I thought it was an excellent presentation. So thank you.
Excellent. Folks, I want to tell you that next Wednesday, we're going to do a lightning round. So it's your turn to talk about anything that you've been learning about for the past year or two. All right, so next up is going to be Elle. Elle, go ahead.
Yeah, hi, and thank you, Sanjay. Sanjay, I never even took an art appreciation class. You know, I did mainly mathematics and quantitative and business even, but this has been marvelous. And I so much better understand how the mind and art come into play. I mean, I would have guessed it, but I really have a grasp on that. And thank you immensely. Thank you.
Thank you.
Thank you, Elle. So Sanjay, this was great. I mean, so what happens is that people underestimate how much the brain is doing when it is processing things and how many connections it is making implicitly. I think the kind of connection of different senses, like the Kiki Booba experiment of, say, okay, there is Kiki and there is Booba. What do you think? There is one figure with sharp edges and one kind of cloudy figure. Which one is Kiki and which one is Booba? One of them is purple, one of them is orange. Which one is Kiki and which one is Booba? So it's like all these senses are kind of, our mind kind of brings things together. And we are always trying to see patterns. So I think you did a fantastic job of looking at the patterns at the sensory level, and just showing how rich the experience is. So I thought that was fantastic. Okay.
The example you gave, Kiki Booba, is Ramachandran. He's a famous neuroscientist. That's an example of synesthesia at play in normal people, because, and if you watch he has TED Talks and many videos that you can see the full version where he really does a great job of it. And he uses visuals to help guide us through. But the concept of Kiki, the auditory sounds of Kiki are very, very sharp sounding.
Yes.
Visual sounds of very sharp angles, like spikiness, right? So this is an example of what happens in a synesthete's mind, is that when they hear a sound like Kiki, right, they see sharpness, they see spikiness, or they might feel it in their skin. Yeah. So that's an example. And to some extent, and Booba is like this amorphous, roundish, like cloudish kind of, mellow sound, which resembles circular objects, clouds maybe. So that's an example where he uses this, there's so many types of examples in neurosciences where they're great examples that explain these concepts. These concepts are fairly well understood, what I discussed tonight. Excuse me. And you can, if you're interested, explore yourself, but also be careful, because on the internet, there's also a lot of things that are false, or they may explain things at one level, they're correct, but they may not be generalizable. So you have to be careful just taking, you have to rely on not everybody can read papers. It's very difficult to read some of these papers, but I would recommend certain, especially .edu sites, educational university sites. They tend to balance the presentation of information.
Sanjay, do you have ideas about what kind of things you'd be doing next in this neuroscience series? What are you thinking of? You don't have to decide anything, but just what topics are you thinking of? So you can give kind of a heads up for people.
I I really haven't thought specifically. I mean, there are many, many ideas that I have floating in my mind about. I mean, so I brought up the idea of consciousness. That's something that long-term I definitely want to get into, because that's something, it's complex, but also I believe it's something that can be explainable and somewhat understandable. And even in these years, this is still the infancy of neurosciences. Scientists are finding enough to be able to put ideas that can help explain it to us and make it actionable. We can rely on these concepts around our consciousness and awareness. Other ideas that I have thought about. I earlier had a very different concept I had a very different thought of how I was going to present perception. And I may go a little deeper into perception in other ways because, for example, our visual system is extremely complicated. And that's because it's one of our most important senses.
Are you familiar with the work of Gibson, J.J. Gibson?
A little bit, yeah.
Okay.
So that's something that I wanted to go into with. I'm not sure. I mean, what I don't want to do is I don't want to have very technical discussions that go beyond what people are interested in. So that's why I didn't do that yet. I may not even go into that because I suspect that may be too technical. But it's very curious because once you start to understand that, once you understand how our vision works, a lot of things about how we function really start to make sense. Even when you're talking about art. Other things that I've thought about are when we experience, so for example, relationships and how we have relationships with other people, with objects, with situations. So the concept of relationships, that's something I've thought about going into. Although the challenge is that each of these elements require a certain bit of knowledge in advance of, for us when we discuss it. For example, David and Kevin, they raised questions around consciousness, and they wanted to delve into it. But I think it's premature for us to do. I definitely want to, and I intend to, for both of you, but also for everyone else, I intend to go into that. But it's very difficult to talk about those things without having other understanding. And similarly, when we talk about relationships, especially very emotional ones, it can be difficult to talk about those. So I've got to figure out what I need to present first. So I'm grappling with the technical aspects of the science that I need to convey first before we get into understanding the complex things about us in the world.
I just wanted to say that you're doing a remarkable job because it's a very hard thing to do. Because on one hand, you want to be true to science. You want to give a perspective. You want to leave out kind of these spurious things. You want to leave out things which are kind of minor things. You want to just look at large patterns. But for that, you need a much wider range of input in order to, and analysis in order to say, okay, what to focus on. Secondly, you are taking everybody's knowledge up a notch. It is a little bit of stretch, but not too much of a stretch. And that can be seen by the fact that people stick around and listen to you for all this time. It's a very complex kind of material coming their way, but and you can see from the questions that they are very engaged. So I think it's working out very well. So look forward to the next one, whatever it is. Okay, and looking forward to all the topics that you're considering are really fascinating, and all the topics you've done are fantastic. So looking forward to it. All right, folks. So thank you very much. We'll see you soon. Bye.